Hello everyone, welcome to the course on Artificial Intelligence in Industrial and Management Engineering. We are talking about text classification, and let's say you have completely developed your model and now you want to understand how good your model is. So you need some kind of evaluation matrices like that you have in your linear regression models. So while talking about various kinds of linear regression models, we talked about different evaluation matrices like mean absolute error, root mean square, or your R square values, right? Similarly, classification, since classification is a completely different supervised learning technique, we have different kinds of evaluation matrices like accuracy, recall, precision, and F1 score. So today we will try to understand what are these different kinds of evaluation matrices and how we can utilize this. So let us start. The prominent matrices classification are like accuracy, recall, precision, and F1 score. So if you have binary classes, then classification can be either correct or incorrect, right? In the case of binary systems. So what we do is we first vectorize the raw text into its vectorized version, right? So we have already seen a technique like TF-IDF for doing this. After that, how we can evaluate the accuracy is, let's say we have the formula for accuracy is correct predictions divided by total predictions. So if you have 80 instances out of 100 correct, then you have 80 by 100, that is 80% accuracy. Okay, but accuracy is useful only when the data set is balanced. So what do we mean by balanced or imbalanced data set is? Imbalanced classes could be, let's say you have 90 correct classes and only 10 incorrect classes. Here these classes are like your labels in your data set. So if your data set has only 10 incorrect labels in your data, then your machine learning system has not seen enough data that is incorrect, right? So the prediction model that you are building is already inclined towards one kind of class, and you are only talking about binary system here. So out of these two classes, you are showing more correct class data, right? So that is why the accuracy evaluation fails. Failure of accuracy metric in these kind of cases, these kind of imbalanced class cases. Your next metric is recall. So this is nothing but the proportion of actual true instance with total true events, and this includes events that classification model has rejected. The third is precision. So these are the proportion of actual true instance with total true instance, and this includes that our model has reported. So you may ask, what is this actual true and the total true? So let to understand this, let us consider that you have created a classification model, okay, and your model is saying some instances as true or false, right? But in your data set, since this is a supervised technique, so in your data set you have the correct actual labels for that instance as well, right? So if there is a difference between what your model is suggesting about the instance and if what the actual instance label is, then you need to tweak your model so that your model can understand your instances better, right? So these differences, to quantify these differences between the model output and the actual labels, we utilize these different classification matrices. So there is always a trade-off between your recall and precision. Okay. Now the third metric is F1 score. So this is the harmonic mean of precision and recall. Okay. Now why do we utilize recall and precision? Because precision or recall can provide better insights for imbalanced data, and F1 score balances precision and recall, and we utilized F1 score when both precision and recall are of high importance. Okay. So now let us understand what is the confusion matrix and how can we utilize this to understand better all of these matrices that we have just talked about, right? So this confusion matrix is useful for assessing the performance of the classification model, and it is a visual representation of comparing actual classes against the predicted class labels, and it can help diagnose types of error that our classification model makes after development. Okay. So let us now create this matrix. So let's say you have only two categories, positive and negative, in your data set, and every instance in your data set has already been classified as actual positive or actual negative, right? So this actual positive and actual negative comes from your data set, and by looking at the same instance, if your model can either say it is a positive or a negative, so this is the predictive positive or predictive negative. Now if your model is saying that the current instance is positive and your actual label of that instance is also positive, then it is true positive. Okay, so this can be represented by TP. Now let's say your instance is actually positive, but your model is predicting it as negative, so this is false negative. So here your model is failing to identify that it was actually a positive label, but your model is predicting it as negative, right? So this is Fn. Your third case could be that your current instance is actually negative in your data set, but your model is predicting as positive. So this is false positive, and it can also written as Fp. Finally, your actual label is also negative and your prediction is also negative. So this is true negative. Okay. So we have talked about accuracy earlier. Now we will utilize this accuracy and develop its formula by looking at the confusion matrix. So accuracy is true positive plus true negative divided by all of your predictions, that is true positive plus true negative plus false positive plus false negative. So what accuracy actually evaluates to is how many times your model is finding the instances correctly. So only the ratio of true positive, the summation of the ratio of true positive and true negative divided by all your predictions, right? So this is the accuracy of your model. The precision, you can also write this as the overall correctness of the model. Okay. Your precision is true positive divided by true positive plus false positive. So what it shows is your precision is how many times your model is predicting something as correctly as possible divided by all those times that your model is saying something as positive, right? So in the complete confusion matrix, your model is labeling something as positive only in this instance and in this instance, right. So, out of these, how many times your model actually predicted something correctly. So, this is the precision. So, the proportion of finding something correctly out of all those instances where the model is finding, where the model is labeling something correct, right. Finally, your recall is true positive divided by true positive plus false negative. So, what recall shows is, let us say you have your instances labeled as positive. Now, out of all those predictions that your model performed labeled as predicted positive or predicted negative, how many times your model says that a particular instance is labeled correctly out of all the instances of actually positive labels, right. So, this is why your precision and recall will always have a trade off. That means, if you are trying to tweak your model in a way that your precision increases, your recall may go down. But to overcome this issue, you usually calculate F1 scores, and this is the harmonic mean of these two proportions. So, the formula for this is precision into recall divided by precision plus recall. So, if you increase your F1 scores, you in the backend what you are doing is you are trying to improve both your precision and recall for the model, right. Now, let us start our coding session so that we can understand how to implement these things in the Python ecosystem and how to implement all those things by utilizing the scikit-learn library. So, to showcase the text classification problem, we have created a synthetic dataset of industrial feedback for some kind of product, right. So, it looks something like this. Here you have feedback from the users which has been developed synthetically, that means by a machine, and these are the labels that has been created by the machine. Now, let us first try to create our own environment. So, we will open the terminal and we will create a new Python environment by using the command Python m. By running this command, Python will create a new folder automatically, which will include 3 subfolders, include, lib and scripts. In under your scripts, there are different kinds of activate scripts that have already been written to activate this environment, right. So, let us now activate this environment. Now, you can see here that we have already activated our environment with the name AIIME_env, right. Now, we can install our libraries to conduct our natural language processing. So, to do that, we will install pip install numpy pandas matplotlib for visualization, spaCy for text related models, and for Jupyter to utilize the Jupyter notebooks. I hope you all have installed your Python environment for conducting our analysis. We have removed the installation time, but it depends on your machines how much time it will take, right? So let us now clear the terminal screen and now start our Jupyter notebook using the Jupyter Lab environment. So you can initialize a new notebook here, and you can see here that there are only 3 items in your current directory. Okay, and this is your environment that you have created. These are 2 different files. Now let us create a new notebook. So this starts with untitled. You can rename this by utilizing the file menu and rename notebook. Let's say NLP. Okay, so now let us start importing our libraries. Import numpy as np, import pandas as pt, and we can import spaCy library which we have already installed. Okay, so what we have not yet installed is, we have talked about installing the language model for spaCy, right? So to install something else, we can utilize this terminal and we can again activate our environment. So we have activated our environment in this terminal that runs inside our Jupyter Lab, right? So you can utilize this terminal as well for installing something new. So you can write python -m spaCy download en core web _sm. So what this will do is, it will find the spaCy library and download this module for that library, which contains the language models for English core for the web form, which is a small model. You can use LG here for large model, but it will be very heavy for maybe for your machine. So now you have downloaded and your installation is successful for this model. Okay, you can close this terminal or you can keep it open. Now you should create a object, let us say NLP, and import or load this model that you have just installed, that is en core web _sm, right? So now you have a model and this is for English. Okay, that is why en is in the starting. So now let us create some text, because we are trying to conduct our natural language processing pipeline. So let us write here the new arena software significantly boost our manufacturing productivity by 44%. This innovative solution implemented at our facility in San Francisco has streamlined complex workflows. We are planning to deploy another 100 industrial robots across our global plants by fourth quarter of 2028. Okay, so this is a text that you have just written, and now this could act as a natural language or unstructured text corpus for your downstream analysis. So first step is to pre-process the text with spaCy. How to do this? We can store this complete text in our document by utilizing the NLP object that we have created here, right? So we can give this as an input to the NLP object. Now we can write that we will identify the tokens and part of speech tags from the complete text automatically. Okay, so to do that, this command has already created tokenization for your complete text. Okay, so we can write for token in doc object print, let's utilize as strings token is token dot text part of speech tag is token dot pos underscore. Okay, so what we are doing here is we have created a for loop with this statement on our doc object, and doc object contains various things, but right now we are only extracting the tokens and the part of speech tags that have already been created by the spaCy library in the NLP object. Okay, so the original text of your corpus is stored in your text object, right? So with the dot operator we are extracting token dot text to identify what is the actual text. Then with the tab character we are writing the part of speech as well for that text, which is identified by the spaCy library. And to get the part of speech tag you have to write pos underscore attribute from your token object. Okay, so our sentence started with the new arena software, right? So all of these, the for loop has already extracted the same things. The first word was the, then new, then arena, then software, and the part of speech for this is determinant, then adjective, then preposition, right? Software is noun, significantly is adverb. So these kind of part of speech tagging is actually done very easily by utilizing the spaCy library. Here you can also see that it already identified dot like the full stop as the punctuation character. Okay, so this is how the your complete document is identified between your tokens and part of speech. Now comes the next part, that is lemmatization. So to do that we can again create a for loop for token in doc print token dot text So now we are identifying the lemmas from our text. What was lemma? Lemma was nothing but the actual base of your words, right? So let's say if your word is like is or are or the or something like that. So out of all these words, is and are have the base or dictionary form as be, right? So that is why you can also see here if there are those kind of words. So let's say we are. So the lemma for are is be. Okay. Planning is reduced to plan. So we are trying to reduce the words to its base or dictionary form here. Next step is to identify the name entities. So for token for ent in doc dot ent yes print. Okay. So now what we are doing here is we are trying to identify the entities, named entities from your text. So what we can utilize is we have created the simple for loop and we are utilizing the ents attribute from your doc object. The doc object was created by your spaCy library here. Okay. So this doc object contains different attributes and now we are trying to utilize ents attribute to identify the entities, and we can label those entities by utilizing the other attribute from ent as label underscore. Now spaCy can also explain what is this named entity. So to do that we are utilizing the explain function from the spaCy library here. So these are all the identified entities from your text, and the first entity is arena. Arena is something the spaCy has labeled as organization, company, agency, institution. So arena is a software and this is actually the name of the software. So it is identifying it as an organization. Secondly, entity like 44%, this has been labeled as percentage, right? San Francisco is a location, so it is labeling it as GP like countries, cities or states. So these kind of entities, if your machine can easily identify these kind of entities from your complete text automatically, then your most of the downstream tasks get very easy, right? So that is why this spaCy library is highly efficient and is very useful. Now coming back to our classification problem, to conduct our modeling of text classification models, we need to import some other libraries as well. So we have already imported pandas, but we need to install a library named scikit-learn. So to do that you can write pip install scikit-learn. Okay, so we have installed this library. So now let us write our import statements. Import pandas as pd from scikit-learn, that is sklearn dot model selection, import train test split from sklearn dot naive base import multinomial in knife base from sklearn dot matrix import confusion underscore matrix and confusion matrix display. Finally, we can also install one more library named matplotlib for visualization. Okay, so it has already been installed. We can write here import matplotlib dot pyplot as plt. Right. So now I have already shown you the data set. Right. So we can import this industrial feedback.csv and it looks something like this. So we have around 5000 instances of customer feedback and each have been labeled, and this is a synthetic data. So we can store this data frame into df variable and we can write pd.read underscore csv industrial feedback.csv. Okay, you can find the info using df.info. Right, so there are 5000 non-null object of feedback and similarly for labels. Okay, now let us again split the data set. So your input data is x and you can filter out only the feedback column. Your labels should be stored in y. So df okay. Now to develop the machine learning model, we need to segregate our data set, our input data set into train and test, right? So to do that, we will create x underscore train comma x underscore text y train and y test, and we can utilize train test split function from scikit-learn. It requires input which is stored in x and the labels which are stored in y, then your test size, let's say we are using 65 and 35 or 75 and 25, so 25%, and your random state as 42, and one more criteria, that is stratify is equal to y. So this stratify will maintains the class imbalance, so it will maintain the class imbalance because our input data is already an imbalanced label data set, right? So now we have segregated them. Now the next step is to vectorize. We have our data set into different training and test arrays. It is the natural language data. So to transform it into numerical data, we need to vectorize it, and we have already studied about TF and IDF, right? So we will utilize this TF IDF vectorization. So we first need to import a library from sklearn dot feature extraction feature underscore extraction dot text import TF IDF vectorizer. Okay, now we can utilize this function vectorizer equals to and your x underscore train underscore vectorized will store the numerical representation of your textual data by utilizing vectorizer dot fit underscore transform and your input textual data which is stored in x underscore train, right? Similarly, we should vectorize our test data as well. X test vectorizer dot fit underscore transform x underscore test. Now these two lines, what they have done is, whatever calculation we have showed in our previous lecture, which we have done on 4 basic sentences, these two lines have completely conducted all those calculations behind the scenes and has stored the vectorized form of the natural language data into these two variables. Okay. Now let us utilize our multinomial naive Bayes algorithm. So this is a simple algorithm that is very useful for developing our classification algorithms, right? So we can store the instance of this function into classifier variable and we can utilize multinomial naive Bayes. Okay, and we can now directly fit our data classifier dot fit x underscore train vectorized comma y underscore train. Okay, so now you have created your classification algorithm and you have developed this model and these are the different parameters. Okay, now again similar to our simple linear regression model, we will try to predict what our classification algorithm is saying about each instance in our data set. So we can write classifier dot predict x test. Okay, so we have our y underscore test as an array. Okay, oh sorry, y underscore pred as an array which stores the predictions for each instance of your this test data set which is already vectorized, right? Now let us try to develop our confusion matrices. So confusion matrix. To do that, we will utilize confusion underscore matrix function which we have already imported earlier, and we will provide y test data, y predicted data and the labels what we need to see in the visualization. So these could be like non-defective and defective. Okay, then we can store this in a variable like cm confusion matrix. Then to show this confusion matrix as a plot, we can utilize confusion matrix display function that we have already included, and what it requires is confusion matrix which we have stored in cm variable, then our display labels which are same, and we can copy it from here. Okay, now let us store this display in a variable named as disp. Now we can plot this disp and we can specify the color map using the keyword cmap as plt.cm dot, let's say blues, blues. Okay, now we need to provide a title of this visualization, and we can write here as confusion matrix for imbalanced and ambiguous data. And finally we can show this visualization. Now what has happened here? We first created a confusion matrix, and the input for that is your test data, test labels and predicted labels, and we have already provided the labels as strings as non-defective and defective. In the next step, we created the confusion matrix display object and created this display, right, which we are seeing here, and we have installed matplotlib, so we can utilize that to create this visualization, right. And this command is providing the color specification for this whole image. Now our data set was imbalanced and ambiguous, so we included this data set so that it is more towards real world, because your customer feedback is usually imbalanced and they are also sometimes ambiguous. So out of 5,000 feedbacks, we have found that non-defective means it is not defective. So the correct means your whatever the feedback was given was correct was 975 for your actual label and for your predicted label, right. Similarly, both were defective when for 265 times, and these we cannot identify any instance where the true label was non defective, but your actual predicted label was defective. So that was 0. So your model is showing that your current classification algorithm deviates only 10 times from your true labels, right. So what this cell means is, when your actual customer feedback was defective, your predictive label was showing that it was not defective. Okay. So this is how you conduct a complete end-to-end natural language processing from your customer feedback, and you can create a text classification process so that you can identify or understand what is the actual perception of your service or your product with the customers, right. So we can stop here and we will continue with a new topic in the next lecture. Thank you.